Lesson 8-5 Graphing Systems of Inequalities, and the objective of this lesson is to solve systems of inequalities by graphing. Why is it important? Because you can use systems of inequalities to solve problems involving travel and nutrition. Let's take a look at this real-world application. Unemployment. Unita tries to her job, or sorry, Unita likes her job as a babysitter, but it pays only $3 per hour. She has been offered a job as a tutor that pays $6 per hour. Because of school, her parents only allow her to work a maximum of 15 hours per week. How many hours can you need a tutor and babysit and still make at least $65 a week? Okay, so this is a classic example of systems of inequalities problem. Okay, so again, just like any word problem, we start with the let statement. So let X represent the number of hours Unita can babysit each week, and let Y represent the number of hours she can tutor each week. Since both X and Y represent the number of hours, okay, neither can be a negative number. That means we are only dealing with quadrant 1 in our coordinate system. Okay, so thus X is greater than or equal to 0 and Y is greater than or equal to 0. And the following system of inequalities can be used to present the conditions of the problem. Okay, so X is greater than or equal to 0, but because it cannot be negative, and Y is greater than or equal to 0 as well. Okay, uh, and another way to do this, because it can be another equation that we, another inequality that we can write would be 3x plus 6y is greater than or equal to 65. Let's explain this inequality. 3 represents $3 per hour that she babysits, and 6 represents the number of the amount she earns per hour when she tutors. Okay, and she wants to earn at least. That's why the inequality greater than or equal to $65. Okay, 65 right there. The second inequality will be x plus y is less than or equal to 15 because she is not allowed to work more than 15 hours, or the inequality is less than or equal to 15 hours, maximum that she can work. So those are the two inequalities. Okay, so the solution of this system is a set of all ordered pairs that satisfies both inequalities and lies in the first quadrant. And that's what this is ensuring, that it lies in the first quadrant. Okay, the solution can be determined by graphing each inequality on the same coordinate plane. Okay, now before we do that, let's recall this. We need to recall, okay, let's say here, yeah, we will solve this in GeoGebra. We'll open that up. Let's recall one thing. The graph of each inequality is called a half plane. The intersection of the two half planes represents the solution to the system of inequalities. So when you talk about graphing an inequality, if you graph both inequalities, okay, the solution would be the intersection of the two half planes. Okay, the solution is the region that contains the graphs of the infinite number of ordered pairs. Remember, when you talk about systems of inequalities, okay, when you're graphing an inequality, you have an infinite number of solutions. Okay, so the boundary line of the half plane is solid and is included in the graph of the inequality. Why is it solid? Because it's less than or equal to and greater than or equal to. Boundary line of the half plane is dashed and is not included in the graph if the inequality is less than or greater than. So remember that. It's a little bit of review. Okay, the line would be solid if it's less than or equal to or greater than or equal to, and it's a broken line or a dashed line if it's less than or greater than. Okay, so let's graph this. You have 3x plus 6y is greater than or equal to 65, and x plus y is less than or equal to 15. Okay, so let's open my GeoGebra right here. Okay, 3x plus 6y is greater than or equal to 65. Okay, if we graph that, make this bigger, and let's do the grid. Okay, do that here, and we graph the inequality 3x plus 6y is greater than or equal to 65. Look down here. Okay, so 3x plus 6y, okay, is greater than or equal to 65. That's how we write greater than or equal to in GeoGebra. Greater than symbol first, and then an equal to, and write 65. And click on return. Look where the graph is. Okay. Make it smaller. Okay. There it is, right there. There. Okay. So first we graph the boundary of 3x equals 6y equals 65. That would be the graph of this line right there. Okay. And then remember what we did before. Okay, we tested a point. So in this case, if you want to test 0, 0 in that inequality, if you test 0, 0 in that equality, all points on this side will make the inequality false, and that's why we shade the right side. Okay, so and that's a graph of 3x plus 6y is greater than 65. Now, and we're only dealing with quadrant 1, remember, okay, so we don't need to show the other quadrant. Now let's enter the second equation, x plus y is less than or equal to 15. So look down here in the input part, okay, so the input part down here will be x plus y is less than or equal to 15. So x plus y, okay, is less than equal to 15. Okay, then click on enter. Look where the graph is. Again, another solid line because it's less than or equal to. Okay, and that's a graph of x plus y is less than or equal to 15. Where the graph intersects will be, okay, the solution. And in this case, this is where it intersects. Right here, the dark blue shade. Now, if you notice, okay, all the points inside this shaded region, okay, right here, we're only talking about, remember, only talking about the first quadrant because we're talking about a positive, the x and y cannot be negative. So we're just talking about quadrant 1. So everything, all the points in this shaded region will make both inequalities correct. And that is also the solution of our inequality. Okay, so that in the solution of these two inequalities will be the one that I just showed you. Okay, and it goes to show the graphs of 3x plus 6y equals 65 and x plus y equals 15 are the boundaries. We talked about that, and they're included in the graph of this system. Okay, because the inequalities are greater than or equal to and less than or equal to, and x greater than 0 and y greater than 0 ensures that it's only going to be in the first quadrant. So every point in this region is possible solution to the system. Okay, so for example, since the graph of 5, 9 is a point in the region, okay, so if you look at our graph again, right there, 5, 9 is one of the points there. So if you look at 5 right here and 9 right here, okay, so this is that point right there, and that's what they're talking about. It is one of the points in that region, 5, 9. So right there, close enough, 4.79, 9.18. Okay, so if the graph of the graph 5, 9 will be one of the solution, what does that mean? It simply means that, okay, Unita could babysit for 5 hours and tutor for 9 hours. Okay, so in this case, she would make 3 times 5 plus 6 times 9, or $69 per week. Okay, so does this meet her requirements of time and earnings? Yes, it would, because 5 9 represents 5 plus 9 would be only 14 hours of working per week, and at least $65 that she would be earning per week. Okay, let's take a look at example number 1. Solve each system of inequalities by graphing. You have y less than 2x plus 1 and y greater than or equal to negative x plus 3. Again, in order to graph these two inequalities, we need to graph the boundaries. So the first inequality, the boundary is y equals 2x plus 1. Okay, and the second inequality, the boundary is y is equal to negative x plus 3. In the first equation, right here, our slope is 2 over 1, and our y-intercept is 1. Second equation, our second boundary, our slope is negative 1 over 1, and our y-intercept is 3. So let's graph the first equation. Y is equal to 2x plus 1. Y-intercept is 1, so y-intercept is 1 is right over here. Okay, since our slope is 2 over 1, we go 2 units up, 1 unit to the right, so right there. So we simply connect those points. That'll be the graph of that equation, and it's a dashed line. Why is it a dashed line or a broken line? Because we're talking about less than or equal to. And let's test the point. 0 0 would be a good point. So if y is equal to 0, x is equal to 0, 0 is less than, question mark, is it less than or equal to 2x, or 2 times 0 plus 1? And you find out that 0 is less than 1. That makes a true statement. So that means everything that is shaded, okay, to the left of the half plane where 0 is would make the inequality true. So we shade that with yellow. So we shade this with yellow. Everything here would be yellow right here. Okay, so everything to the right of that half plane would make our inequality true. So let's graph the other one, the other equation. Y is equal to negative x plus 3, and our y-intercept is 3, so right over here is 3, and our slope is negative 1 over 1, so that means go down 1 unit, go down right to the right one, and then we simply connect the points. Okay, and the points will create this line right here, right there. Okay, so it's a solid line because it's greater than or equal to. The boundary has been formed by this equation, y equals negative x plus 3, which tests the point in 0, 0 again. So if we test 0 0 right here, is 0 greater than or equal to negative 0 plus 3, and we find out that 0 greater than or equal to 3 is a false statement. That means everything to the left of our half plane will make the inequality false. So we shade, okay, the right side of our half plane, and where the inequalities, the graph of those inequalities intersect, okay, will be the solution of our system of inequalities. This will be the solution of our system of inequalities. Okay, so let's summarize this. The solution includes the ordered pairs in the intersection of the graphs y less than 2x plus 1 and y greater than or equal to negative x plus 3. Okay, this region is shaded in green, okay, not really in green. Okay, at the right, the graphs of y equals 2x plus 1 and y equals negative x plus 3, okay, are the boundaries in this region. The graph of y equals 2x plus 1 is dashed and not included in the graph. We talked about that. And y less than 2x plus 1. Okay, so the graph of y equals negative x plus 3 is included in the graph because of y is greater than or equal to negative x plus 3, and it's a greater than or equal to sign. Okay, and that is, okay, example number 1. Let's take a look at example number 2 or 1b, 2x plus y greater than or equal to 4 and y less than or equal to negative 2x minus 1. Okay, and let's see how we can graph this on GeoGebra. Okay, the equation is y equals, 2x plus y greater than or equal to 4, so we write it here, 2x, okay, plus y greater than or equal to 4, greater than or equal to 4. Okay, and if you notice, this is the graph of that inequality. Okay, it's a solid line since it's greater than or equal to, and we shade the right side of the half plane. Okay, simply because if we test the point, 0, 0 in this inequality, okay, it will make the inequality false. That's why we shade the right side. And again, to be able to find that boundary right there, that solid line, we need to graph 2x plus y equals 4. Okay, and then let's graph the other one, y less than or equal to negative 2x minus 1. Okay, so y less than, okay, less than or equal to negative 2x minus 1. Negative 2x minus 1. And if you graph that, look carefully what's going to happen. Okay, you're going to have a solid line again. Okay, and you shade the left side of the half plane. Simply because if you test the point 0, 0, okay, that point will make the inequality false, and that's why you shade the left side. Now, what do you notice in this inequality? This system of inequalities, okay, you cannot see overlapping, okay, solutions. That means as you shade the first inequality, okay, and you shade the second inequality, none, okay, none of the solutions for both inequalities will overlap or will intersect. Okay, so that means in this particular case, there is no solution, okay, to this inequality. So the graphs of 2x plus y equals 4 and y equals negative 2x minus 1 are parallel lines because the two regions have no points in common. The system of inequalities has no solution, and that's the reason why they don't overlap, okay, simply because they have the same slope, and their slope, both of their slopes are negative 2, and since their graphs don't overlap, okay, and they're parallel lines, there is no solution to this system of inequalities. Okay, and let's take a look at example number 3. Sometimes in real life problems involving systems, only whole number solutions make sense. Let's take a look at this application. Elena Ayala wants to spend no more than $700 for hotels while vacationing in Hawaii. She wants to stay at the Highville Resort at least one night and at the Coral Hotel for the remainder of her stay. The Highville Resort costs $130 per night, and the Coral Hotel costs $85 per night. If she wants to stay in Hawaii at least 6 nights, how many nights could she spend at each hotel and still stay within her budget? She does not want to stay or spend no more than $700. So that's the maximum. So our inequality will be less than or equal to for one of them. What advice might you give Elena after her options? Okay, again, we start with a let statement. Let C represent the number of nights she will stay at the Coral Hotel. H represent the number of nights that she will stay at the Highville Resort. In that case, the following system of inequalities can be used to represent the conditions for this problem. Okay, H plus C is greater than or equal to 6 because she wants to stay at least 6 nights, and the inequality greater than or equal to means at least, and H is greater than or equal to 1, Y1, because she wants to stay at least one night at the Highville Resort. Okay, and another inequality would be $130 per night for the Highville Resort, $85 per night for the Coral Resort, Coral Hotel, Okay, and when she spends that, she doesn't want to spend no more than $700, so less than or equal to $700. So those are the three inequalities. Okay, the solution is a set of all ordered pairs whose graphs are in the intersection of the graphs of these three inequalities. So when we graph these three inequalities, the solution will be the intersection of all three graphs. Okay, so if we graph them, okay, this is what's going to come out. We'll make it fast. Okay, and what does it say here? Oh, we will solve this in GeoGebra. Okay, let's solve this in GeoGebra then. Okay, so if you solve this in GeoGebra, and let's go back to our GeoGebra and let's look at our inequalities here. Oh, no, not that one. This one right here. And we'll clear that. New, will not save this. Okay. And let's graph the first one. H plus C is greater than or equal to greater than or equal to 6. And in this case, we'll just use x plus y. X plus y is greater than or equal to 6. Okay, graph that. That is the uh, graph of that inequality. The next inequality is h is greater than or equal to 1. Greater than or equal to 1. This is the graph of that inequality right here. Create sliders. Okay. You know what? Okay, let's undo that because there is no variable h, and we'll represent it with x. X is greater than or equal to 1. That's the one. There you go. So that's the graph of that inequality. X is greater than or equal to 1. And the final inequality is 130x plus 85c is less than or equal to 700. Less than or equal to 700. Okay, and if we graph that, this is how it's going to look like. Oops, because I cancel that, baby. Cancel that, and we need to put this as a y, not as a c. There you go. And we simply create enter there. Okay, and if you notice, okay, this is the graph of our inequality, and the solution will be the intersection of all three graphs, which is this part right here. Okay, and if we get that part right there, okay, and then we cut that out, so we put it where our problem is. Okay, and we put it back here, paste that here. Let's make that smaller so we can still see right there. Okay, so let's pretend that region is brown. Any point in this region is possible solution. However, only whole number solutions make sense in this problem. Why? Because obviously you cannot spend half a night or 1/4 a night in one hotel. Okay, so for example, since 3, 3 is a point in the region, okay, 3, 3 is a point in the region, we know that's inside. Elena could stay 3 nights at each hotel. Okay, in this case, she would spend 3, okay, times 130 or 390 at the Highville Resort and 3 times 85 or 255 at Coral Hotel for a total of $645, which is still way below $700. So the solutions are, if you're only looking for whole number solutions, 5, 1, 6, 1, 4, 2, 5, 2, and 2, 4. those are the only whole number solutions that will fall inside that little triangle right there. Okay? So, what advice we give her? We could advise Elena that she could stay in the Hawaii for a maximum of 7 nights. And if she stayed at the Highville Resort for only 1 or 2 nights, and stayed at the Coral Hotel for the remainder of her vacation. Okay, so that's one thing that we could tell her. She could stay in Hawaii in a maximum of 7 nights. If she stayed at the Highville Resort only for 1 or 2 nights, and the rest of the stay she will be at the Coral Hotel. Okay, and this is how you graph your system of inequalities. And the secret word for this particular lesson would be blazers. Secret word will be blazers. Thank you for watching.